Hey guys, have you ever wondered how those kitchen hoods, those big industrial kitchen hoods that are over top of fryers and flat top cookers and woks and those are tested? Maybe perhaps you guys have worked in a restaurant or worked around as a server in a restaurant, and you see these gigantic hoods with these nozzles coming down, and wondered, how are those tested, or maybe how do those work? Well, I'm actually going to do a bunch of those today, and I wanted you guys to tag along and kind of see how those things work and how we're testing them. So stick around. So this is a very large kitchen, and you can see all the way down here. This is all one big giant hood system to ventilate all your cooking appliances, and these mostly are gas. Some are electric, but mostly gas. In each one of these, there's 6 total hoods. Each one of these needs to be tested individually, and most restaurants only have 1. Sometimes bigger restaurants have 2. So this is a kind of a unique situation where there's multiple. Each hood has a pull station here. So in the event of a fire or they see something, they can push that button, and then the fire suppressant comes out of the nozzles and onto the flame. So this is above all of the systems here. This is your fresh air coming in, and these are your exhaust lines going out to daylight. So this is the inner workings of each hood. Each one of these hoods has one of these canisters here, and this is by Captive Air. There's some that are made by Ansel, and this has a liquid or a dry agent in it that goes, in the event of a fire, it goes out of this compressed canister and out of the nozzles onto the flame. So in order to test these and allow these nozzles to work, they have to bypass these tanks here. And so they bypass with this hose here into a compressed air system. That compressed air system is activated when they do a pull tab, or the fusible links inside are activated, and air is then rushed through this hose, through the system, and out of those nozzles. So in order to test the nozzles to make sure that there's actual flow going to each nozzle evenly, they put up these little balloons. So when the pull station is activated and fire suppression goes through the nozzles, the system is set up so that the fire or the flame in gas is extinguished to all gas appliances all at the same time. So we're not feeding the flame while we're trying to extinguish it. So he activated the pressure. He's getting ready to push the tab here at the pull station. At that time, the fire alarm goes off. Fresh air is extinguished, and the balloons blow up. So we got one that's not blowing, and one up there. And at the same time, the gas pilots have gone out. Also, the electric has gone out as well. So electric appliances go out as well as the gas, all at the same time during a test. And that signifies that if there is the event of an emergency and we had a fire issue here, that both electric and gas are cut off at the same time that we're trying to extinguish the flame through the suppressant system. So here's an example of some of the nozzles that blew up. These 2 nozzles are directed directly over top of this wok burner. This one is directed above the fryer, which you can see that the balloon did not fully inflate, which means that there may be an issue with either flow or it needs to be adjusted. This one's the same way. That's over top of this grill. The flat top cooker has one, but the other one didn't blow up. And then inside the hood has one, as well as the exhaust has one, and that did blow up. And you can see these 2 did not, and that one did not. So some of these need to be adjusted, and some of them need to be regulated so that we get proper flow out of each nozzle. So that's how an industrial kitchen hood fire suppression system is tested. And I hope you guys learned something and maybe satisfied a curiosity on how those things are even tested or even how they work. But we'll talk to you guys soon. Hope you guys enjoyed.